Let's dive deeper into the components of a PLC system. We'll start with the PLC itself. A PLC is a digital computer used for the automation of electromechanical processes. It continuously monitors the state of input devices and makes decisions based on a custom program to control the state of output devices. Next, let's talk about the 24V DC motor. This motor is responsible for the movement of the elevator. It converts electrical energy into mechanical energy, allowing the elevator to move up and down. The motor is designed to provide smooth and efficient operation, ensuring a comfortable ride for passengers. It works in conjunction with the motor driver to control the speed and direction of the elevator. Understanding this motor is crucial because it is the powerhouse that drives the entire system, making it an essential component in the PLC-controlled elevator design. Now let's delve into another vital component of the PLC-controlled elevator system: limit switches. Limit switches are crucial for detecting the position of the elevator. They send signals to the PLC to indicate the current floor position, ensuring the elevator stops at the correct floor. These tiny but mighty devices act as the eyes of the system, continuously monitoring the elevator's location. When the elevator reaches a specific floor, the limit switch sends an electronic signal to the PLC, which then processes this information to halt the motor and stop the elevator at the precise floor. Limit switches are integral to the overall safety and efficiency of the elevator system. They help in preventing overtravel and ensuring that the elevator aligns perfectly with each floor, providing a seamless and safe experience for passengers. Understanding how these components work together helps us appreciate the intricate engineering behind modern elevator systems. In the next segment, we will bring all these components together in a 3D animated guide to PLC elevator design. Stay tuned. Now that we've covered limit switches, let's move on to another critical safety component in PLC-controlled elevator systems: load cells. Load cells are used for overload detection. These devices measure the weight inside the elevator and send signals to the PLC if the weight exceeds a certain limit. When the load cells detect that the elevator is carrying more weight than it should, they trigger safety mechanisms to prevent any potential hazards. This could mean stopping the elevator from moving or alerting maintenance personnel to address the issue. The PLC processes these signals and takes the necessary actions to ensure the safety of passengers. Load cells are essential for maintaining the balance and safety of the elevator system. They help prevent accidents due to overloading, ensuring that the elevator operates within its safe weight limits. By integrating load cells into the PLC system, we add an extra layer of security and reliability to the elevator's operation. In the next segment, we will bring all these components together in a 3D animated guide to PLC elevator design. Stay tuned. 7-segment displays are an integral part of modern elevator systems. These displays are used for floor indication, showing the current floor number to make it easy for passengers to know their location. When the elevator moves, the PLC sends signals to update the display, ensuring that the correct floor number is shown at all times. This real-time update helps passengers stay informed about their journey, adding a layer of convenience and safety. The 7-segment display is not just a simple numeric indicator, it's an essential communication tool between the elevator system and its users. By clearly displaying the floor number, it helps reduce confusion and enhances the overall user experience. Next, we'll see how all these components come together in a 3D animated guide to PLC elevator design. Stay tuned. Now let's dive into the motor driver, a crucial component in ensuring the smooth operation of the elevator. The motor driver is responsible for controlling the speed and direction of the motor. It takes the commands from the PLC and translates them into precise movements, ensuring the elevator moves efficiently and quietly. Imagine pressing the button for your desired floor. The PLC sends the command to the motor driver, which then adjusts the motor's speed and direction to move the elevator cab. Whether you're going up or down, the motor driver makes sure the ride is smooth, reducing noise and wear on the system. This seamless coordination between the PLC and the motor driver is what makes modern elevators so reliable and comfortable. By controlling the motor's acceleration and deceleration, the motor driver prevents abrupt starts and stops, enhancing passenger comfort and safety. Next, we'll see how all these components come together in a 3D animated guide to PLC elevator design. Stay tuned. Ladder logic is the programming language used to create the control program for the PLC. It consists of a series of instructions that the PLC follows to process input signals and control output devices. Imagine it as the brain that connects all the components we've discussed so far. When you press a button for a specific floor, the PLC receives this input signal. Using ladder logic, it determines the next steps, activating the motor driver to move the elevator, checking limit switches to ensure it stops at the correct floor, and updating the 7-segment display to show the current floor number. Ladder logic is designed to be simple yet powerful, allowing engineers to create complex control sequences easily. It's like a flowchart, with each rung representing a different part of the control process. In the case of our elevator system, Ladder logic ensures everything works in harmony, from the smooth movement of the elevator to the safety checks along the way. By understanding ladder logic, you get a glimpse into the intelligence that powers modern automation systems. Up next, we'll see how all these components come together in a 3D animated guide to PLC elevator design. Stay tuned. Safety features are an essential part of any elevator system. Overload protection and emergency stops are built into the system to ensure the safety of passengers. Imagine you're in an elevator that suddenly stops because it's overloaded. This is where the load cells we discussed earlier come into play. They detect the weight and send a signal to the PLC, which then halts the elevator's movement to prevent any mechanical strain or failure. Another vital safety feature is the emergency stop. In the event of an emergency, pressing the emergency stop button sends an immediate signal to the PLC to halt all operations. This ensures that the elevator doesn't move until the situation is resolved. The PLC can also trigger alarms to alert maintenance teams or emergency services, providing an extra layer of security. These safety mechanisms are not just theoretical, they are rigorously tested and implemented to meet stringent safety standards. By integrating these features, we ensure that the elevator system is not only efficient, but also safe for every passenger. Up next, let's bring all these elements together in a 3D animated guide to PLC elevator design. Stay tuned. Now that we've covered the safety features and the essential components, let's dive into the real-time operation of the PLC in an elevator system. Imagine you're in an elevator and you press the button for the third floor. What happens next? In real-time operation, the PLC calculates the shortest path to the requested floor and controls the motor and doors to provide smooth and automated movement. The PLC processes the input from the floor button, checks the current position of the elevator using limit switches, and then determines the most efficient route. It sends signals to the motor driver to start the 24 VDC motor, ensuring the elevator moves in the correct direction. As the elevator approaches the third floor, the limit switches signal the PLC to slow down the motor for a smooth stop. The PLC then engages the door mechanism, allowing passengers to safely exit and enter. Throughout this entire process, the load cells continuously monitor the weight to prevent overloading, and the 7-segment display updates to show the current floor. This seamless interaction between components and the PLC ensures a reliable and efficient elevator ride. Up next, let's bring all these elements together in a 3D animated guide to PLC elevator design. Stay tuned. Welcome back. Now that we've seen the PLC in action, let's explore some real-world applications and future innovations in elevator technology. Elevators are not just confined to commercial buildings or residential complexes, they're integral to various sectors, including hospitals, airports, and even in the industrial domain where they facilitate the movement of heavy machinery. In hospitals, for instance, PLCs are crucial for ensuring that elevators can quickly and safely transport patients and medical staff between floors, often integrating with emergency systems to prioritize critical movements. Airports use advanced PLC systems to manage the heavy traffic of passengers and luggage, ensuring timely and efficient operations. Looking ahead, the future of elevator technology is set to be even more exciting. Innovations like IoT integration, predictive maintenance, and AI-driven optimization are on the horizon. IoT sensors can provide real-time data to the PLC, enabling smarter decision-making and reducing downtime through predictive maintenance. AI can further optimize elevator routes and energy usage, making systems more efficient and eco-friendly. These advancements promise to make elevators safer, faster, and more reliable, revolutionizing how we move within buildings. Thank you for joining us on this detailed breakdown of PLC elevator design. For more tech breakdowns, hit like and subscribe. Elevators, the unsung heroes of vertical transportation. Curious about how they work? Today, we're breaking down the magic of PLCs in a 4-floor lift system. First up, PLCs, or Programmable Logic Controllers, are the brains behind the operation. They take input commands, prioritize them, and control the motor and doors. It's like having a mini traffic controller inside the elevator. Now let's talk components. We have the PLC itself, a 24 VDC motor, limit switches to detect floor positions, load cells for overload detection, a 7-segment display for floor indication, and a motor driver for smooth movement. The system uses ladder logic to process requests, detect positions, and move efficiently. Safety features like overload protection and emergency stops are built right in. In real time, press a button, the PLC calculates the shortest path, and voila, smooth automated movement. Thanks for joining us. For more tech breakdowns, hit like and subscribe.